Okay, hello everyone. Before I start, usually this talk is kind of like aiming for developers. So are there any developers, if you can raise your hand? Okay, and remain your hand if you are a Solidity developer. Okay, and any Python developers? Okay, something. Good. So I will try to frame it a little bit in like a bigger picture. Hello everyone. I'm Josef. I'm CEO and co-founder of Ackee Blockchain. We are a security firm. We are doing smart contract audits, which is in developer talk something like a code review. It's not accounting of any kind like Deloitte is doing. And yeah, we've been in the space since 2021. And besides auditing, we are also doing a lot of open source tooling and some education because my background is in Czech Technical University, where I got my PhD in distributed systems in 2017. And actually my dissertation thesis had a blockchain keyword in it, so it was a very OG kind of stuff back in the day. And yeah, we are working for some of the, I would say, industry leaders in the space. So if you know 1inch, Lido, Safe, next week there is a conference, SafeCon in Berlin, or Axelar. So basically these are all the projects we've been working for. And also I'm very happy that we are getting support from the foundations, which are the chains basically. So we got a grant from Ethereum Foundation in 2017, and we also got a grant from Solana Foundation and from Coinbase. And why they give us grant for? It's exactly for the developer tooling, because I believe that the best auditors are the ones that are producing some open source that the other developers and auditors use. So this is how we are trying to build a system. As you are not a Solidity developer, so let's say I would say the best auditing company is OpenZeppelin, and basically they are very famous because they created all the libraries that every Solidity project is using. So basically they have gained their reputation by creating open source that everyone uses, and then they can provide premium auditing services for money. So this is the direction that we are going as well. And before we deep dive into the tooling, I will just do a quick recap of basically like the impact of security practices. For a lot of you, it may be very basic, but believe me, for a lot of the protocols, it's something new. And these things are, I would say here, since the 80s. That's nothing new. So basically, if you are delivering a software project, there are things that you can do very easily and have a huge impact. Such as best practices. Some guys that already developed some software had written down what worked and what not, and it's good to follow that. There is a tooling that everyone can use for free. Then, of course, the next steps require that you need to do something, which is usually writing tests. So again, it's very good to write tests if you're writing software, but it's sometimes new for the blockchain projects. And then I would say like a more advanced approach to writing tests is fast testing, and the very top of the iceberg is audit. That's what we do. That's the manual work. Sometimes the protocols tend to think that like they can deliver garbage code and the audit is the thing that will save them. So no, in that case, basically in the audit we tell them you have to rewrite your code, and they are back in the beginning. But also the auditors are also people. They also make mistakes. So it's very risky, of course, to skip all the layers that are that the teams then can do themselves and much cheaper. Also, auditors are very expensive, so if you make auditors write the integration tests or fast tests, you are just throwing money away. And this is what we tell to our clients. So if we start from the beginning, best practices, you probably know that as tech guys, so it's a very basic thing, but like using Git flow, doing peer review between each other, it really helps. And also sometimes we have there are like superstars in the team that this guy has created Solana programs and Solidity smart contracts. superstars don't exist. The developer should be really focused to one stack and be expert in that. Second step, tooling. So in the space of blockchain, there is a lot of free tools that everyone can use. So for example, for the security perspective, static analyzers are quite commonly used tool, which is free available. The first static analyzer was called Slither. That's by a company Trail of Bits. It's open source. Everyone can use it for free, and it catches some low-hanging fruit. You run it once over the code base, and you get some results. So it's very easy to run, and it's for free, and it takes like 5 minutes to proceed. Problem of these tools are that sometimes they are producing a lot of false positives, and it's annoying. And it's also the reason why usually the protocols, for example, when they integrate it into their process, CI/CD, or just like in the process, they tend to turn it off after a while because it's just producing noise. Let's say a middle layer where there is some action needed, but still the results are, of course, worth it, is writing tests. So integration tests, unit tests, anything. In my perspective, it's always better to write the tests in different language than the software is written in. So for example, if you be testing like JavaScript with JavaScript tests, there's a probability that you copy the same mistake into the test. So it's better to have kind of like different thinking about it. And also it's good that the tests are written by a different person than wrote the code. It's not really like a unit test, but for example, for integration tests, this is definitely valid. And also it's good not to test only the things how it should work. This is the happy path scenario, but also test some cases how it shouldn't work. So also have some kind of like wrong scenarios. And of course, tests should be integrated in CI/CD. And if we like approach to a more advanced stuff, so this, I would say, fastest is thing that in our history we have seen just with the very best top tier protocols that they have written the fastest for themselves. Maybe what is fastest thing, I would say most of you know, but it's some kind of like random trying of random inputs into all possible orders, into all functions. This technique was born when the computers were really simple. So by fast testing, you could just test the code as black box code, which means you were really able to try all the possible combinations. But as smart contracts are quite complex, by this approach, which we call black box fast testing, the fuzzing will never finish. The fuzzing campaign will take years, even on the very modern hardware. So there are ways how to simplify that. One of the approaches is taken by Echidna, which is a tool open source from Trail of Bits, and they introduce something called invariance, which means at least the developer has to specify in advance some kind of assumptions that cannot be broken. So for example, the balance of this wallet cannot never go below 0. If it goes below 0, it's a problem. So it kind of helps to narrow the space. And we, in our framework called Wake, even went further, and we are also defining, which means the developers are defining where the fuzzer should be fuzzing. So we are not giving it like free space, just go everywhere, but we are a little bit like cutting the state space and just telling to fuzz some functions in some orders and not giving it completely freehand. By this, we are able to reduce the fuzzing time from infinite to 10 minutes, for example. But it needs the developer to have some kind of idea, and of course the developer of the fast test must be aware of the project. So this is in theory how software testing in smart contracts should work. And now which frameworks do fulfill that? We have been missing any tool that could basically work for us as auditors. So we had to write it. It was like 2 years ago, we started writing tool called Wake Framework. And what is that? So the first thing we want to integrate is static analysis framework, because from our auditing flow, for example, when the auditors define some or find some issue, some security problem, then always we are thinking, could this happen again? And if the answer is yes, we just go and write a detector, which is a simple snippet of code, which is able to find this issue. It could be, for example, missing modifier. Then the next thing that we were really missing was a very good testing framework. because, for example, Solidity so far doesn't have any production debugger, which might sound for you kind of like funny, but it is that. So we have been really facing a lot of problems just debugging the code. So we have solved this problem. I'll show you how. And we also needed some kind of framework to write very easily unit tests, integration tests. There are frameworks, but we didn't like them, so we just did it our way. And what we were missing a lot was some tooling that would allow advanced fast testing. And I will speak about what does it mean, advanced fast testing. And the advantage of doing all this in one tool is that we can make the simple modules communicate with each other, which the other tools cannot do. And the user can leverage from that. So what we did is that all of the modules have a language server, which is a protocol that can communicate to extensions in developer environments. And we have written an extension called Tools for Solidity for Visual Studio Code. So basically, when user installs this extension, all the outputs from the framework are visible in the extension. I'll show it later. So this is how look the vulnerability detectors. This is the output in command line. So basically, when the tool discovers some possible issue, it just highlights the line where is the issue and writes, in this case, it's unsafe variant of ERC20 call, and the developer can investigate. So it's easy like this, you run it, and here you have the result. Then, as I was telling about debugger, so we solved it that way that we have basically transferred the problem by using Python and PyTypes. PyTypes allow to create custom types in the Python language. So we basically created something like a Solidity model in Python. And when we just run the framework, it automatically generates a model of the Solidity contract in Python, which means we are not debugging Solidity, but we are debugging Python. And by this, we are able to use all the tools that are available for Python developers, which is very mature ecosystem. So for example, we can use Python debugger to debug Solidity code. And here you can see it in action. So we are running some simple test. And now it crashes on this line because there is some kind of problem. And now the developer can easily look and investigate what is the problem, which means we can look at the variables and we can even call things. And this way we are just using IPDB, which is a Python debugger over a smart contract written in Solidity. So this is what we needed as first as auditors, because without this, we are not able to basically do our work. Then I was speaking about fast testing. So in our case, there are two things required from the developer to provide, which are the invariants, which are the things that can never happen, and then something we call flows, which is basically the single atomic test that is run in a campaign. So we are here defining which basically code blocks should the fast test visit. And by combining this, we are able to go further. And for example, in case of DeFi protocols, which basically is a huge code base, a lot of mathematics in that, and also these protocols use a lot of external libraries. And with auditing is always, budget is of course the problem because it's manual work. So the clients, when they, for example, use some library, of course don't want to pay the auditor to audit also the library, because the argument is quite clear. The library is used by many other protocols, maybe it was already audited, but still it's kind of like a problem that can happen. And fast testing is a very nice solution for that. We have been auditing DeFi protocol called Hyper, and they were using some Solidity library for mathematical interest rate floating calculations. And we are just like not really sure about this library. So we have taken a similar library that was written in Python and that is much more mature. And we just wrote a fast test that was running once against the Python model of the code we wrote and once against the deployed contracts. And we were just checking if there is a difference between the results returned from the protocol and between the results that were using the Python library, not the Solidity library. And we have seen that there it was returning different numbers, which means something was wrong. And of course, then we investigated and found out that in the library itself is some kind of like rounding error in Solidity, which in the case of a DeFi protocol could have huge consequences. And it was a very, let's say, regarding the time, cheap way how to find a problem without auditing the library, just by the differential fuzz testing, discovering that it's returning wrong results. And does it work? Yes, it works. These are the findings we have had just using the framework, not the manual code review in some of the high-profile protocols. All of this is open source, so it's on our GitHub. So our latest catch is a medium severity issue in Lido, which is staking protocol that has basically staked something like GDP of Switzerland is staked in the protocol, so it's like really a big protocol. Medium, of course, is nothing dramatic, but it could be a problem. And it's in Python, so sometimes I'm getting a question, what about the performance? So, of course, Python is slow, but developers are smart, and we are doing something called partial compilation, which means we are not recompiling the test every time we change things. So we have just created a test suite. Major protocol is called Uniswap, and they have implemented their test suite in a framework called Hardhat, and it consists of 271 tests. And we have just taken these tests and we have rewritten them by hand. One of my students at the university, not we, to 3 different frameworks, so Wake, Brownie, and Ape. And so we had like 4 different test suites, and we have run these test suites over 3 different chains with these frameworks, and this is the result. So Wake is so far the fastest testing framework. It finished all the tests in 3 seconds, and for example, Brownie, it took 40 seconds, so on the same chain, on Anvil, which is the fastest chain. So we are getting quite a good execution times. This is very important, because if the tests would be taking a long time, it will not survive in the CI/CD pipeline of the projects. They would turn it off because it's taking a long time, so we need to be fast. And here, if you would like to know something about the Solidity space, these are the frameworks that exist, these are the features, and of course we as a newest framework are fulfilling most of that. So this is how it looks. And as I said that we have something extra, that's the front end. So far we have been speaking about a framework, which is a library or CLI tool, but thanks to the integration we have and thanks to the language server protocol, we were also able to create a front end for the Visual Studio. And the front end is just running the framework on background, but it has huge implications for the user, because the developers, of course, are lazy. That's normal, you know. So they are not willing to run some tool over the code base every time. Or if it's in the CI/CD, it's like after they push, like in next week, you know. So it's still kind of like distant from them. But when we make them to use the extension, which is like one-click, completely free, open source, they install the extension. They have like immediately in the VS Code all the outputs from the static analysis. So here you can see the detections that happened in the project, and the developers can react to it immediately. And it also highlights. So for example, when the dev makes, I don't know, reentrancy bug, so the line is in 1 or 2 seconds highlighted, and there is a pop-up text that's telling, hey, possible reentrancy, please check it. And we can also, because it's integrated with the testing framework, we can provide to the developers back feedback and show them visually which lines of code are covered by the test coverage, which is also very helpful if they see it like really in the code, what was covered, what not. And this makes them to write the test, because we want them to write at least test coverage 90%. Before that, it doesn't make sense to audit the code. And here's again, I would say, all possible extensions for VS Code for Solidity. So if there is the one Solidity developer, you probably know that. We are again one of the newest, or we are the newest extension. So we are fulfilling the security tooling and development tooling. And yeah, everyone can install it for free. So if you would like to try it, it's here. If not, and if you would like to have any question about smart contract auditing or security, the talk is finished. Thank you.
Yeah, thank you, Josef, very much. Any questions? Yeah.
Hi, Christoph from ETH Zurich. I have a question. Really nice talk, by the way. Have you, so the tools that you showed, they were mainly like tools from the industry, developed by the industry. Have you thought about comparing tools from academia that academia proposed? Because there was a lot of research done, and still is being done, on how to automatically detect bugs in smart contracts, and it's coming from academia. And if you tested those tools, like what are your takeaways from those tools?
Basically, we are testing the tools that is someone using. So, of course, we could compare, but maybe you can help me and name some academia tool. But the way how we are working is just that we are auditing the existing projects. So for us, it really needs to be hands-on and ready to use. So I know that, for example, there are some static analyzers developed in academia, but to be through the Slither, which is the static analyzer from Tale of Bits. They have about 5 academic publications about that. So this project, here, Slither, the first one. This project is partly like academia project, but I don't know about any other academic project that would be really used, to be honest.
Yeah. Maybe can I just give a small comment? Okay. Yeah, Slither, exactly. They released the tool first, and then a few years later they realized, okay, it's a nice paper, so they published a paper about it. No, so one tool, for example, is Confuzius. I don't know if you know about it. It's a hybrid fuzzer. Combines symbolic execution actually with fuzzing. Maybe have a look at it. It might be interesting. Yeah.
Cool. Yeah. For the symbolic execution, I've said a different topic. I'll be happy to follow up.
Other questions? I was moving in the wrong direction.
Yeah.
Amazing tool, Josef, and I love that you make fuzzing easier, because it's something that I personally think is very important, so we can kick more teams to do more fuzzing. A little bit unfair question, but are you looking to expand into formal verification maybe sometime in the future? I know it's hard, but I think it would be super valuable.
That's a very good question, actually, because if you look at formal verification, in the end, how, for example, Certora is doing that, they are writing a model for basically each project that they are auditing with formal verification. And what's the purpose of the model is basically to try all possible states, but just there, I would say, fuzzer is being navigated by the symbolic execution. In our case, the fuzzer is being navigated by the developer, but it's kind of the same thing in the end. So if you just like transform fuzzing for the black box fuzzing to some kind of like guide fuzzing, it's getting closer to the symbolic execution. And we have been actually playing a lot with, to formal verification. We've been playing a lot with formal verification, but we think fuzzing is the way. It's our religion. Certora has a religion, the other thing. But in the end, I think even if you look at the bytecode which is being generated, the results are more the same that someone would think.
So your approach is basically to fuzz so excessively that you're almost like generating a proof, because you have a very high statistical likelihood that you covered all possible states?
Exactly, like the goal of both techniques is to have the coverage of everything, But in the case of fuzzing, it will take so much time, so we are just like telling the fuzzer where not to go, I would say like this, very simple.
Thank you.
Okay. Other questions?
So can your fuzzer like check performance properties? So for example, can it like generate inputs which create like execution paths which are more expensive than others, like for like fine tuning or like optimizing your contracts?
Like if you write it, it can do it, but for the gas optimization, we are more using the static analysis by some detectors that we have already in the tooling. If I answer your question correctly.
But like, isn't like, like, so with static analysis, you kind of do like a resource usage analysis.
Yeah.
But then do you have like some kind of model of what each like atomic execution costs? And is this something that is like built in the tool or has to be like provided?
No, it's more like with the static analysis, we are looking for some obvious like mistake in misusage of the gas. So of course it's not like a coverage of everything. With the fuzzing, it would be possible to count it very precisely, but just like it's not the thing that I would say protocols would be paying us for to investigate their gas usage. But with fuzzing, it's of course possible to do it. And that's why also the framework is like very open. So basically in Python you can just implement this check yourself.